In this video, we learn about another abstract data type called queue. If you remember from the video on the abstract data type called the stack, you remember that when we talk about abstract data types, these are not really data structures because there is no there is no requirement in terms of the implementation, and it's just a description of the operations that is provided with, say, a stack or a queue, and the behavior of these operations. So it's when we talk about abstract data types, abstract data types, or ADTs, what we are talking about is not about the implementation, but a description of the behavior of the abstract data type. Again, if you remember the video about the stack, abstract data type, we said that the main behavior of a stack can be described by the term last in, first out. Now, for queues, what we have as the main behavior is kind of the opposite of that. It's first in, first out, or FIFO. Okay, and that is consistent with the idea of a queue. So if you're standing in a line or in a queue, the idea is that the first person that will be served is the person that has been in the queue the longest. Okay, which means the person that has joined the queue first. So the first person that joined is going to be the first person that is served, or the first person out, right? So first in, first out is the main behavior. And it turns out that in computer science, queues are used in many different applications. For example, if you have different tasks that you're supposed to um, schedule them, then you need some kind of a queue that, depending on the order of these tasks, you put them in a queue, and then one at a time you perform them, right? And that's kind of like what your operating system does, except that it's a little bit more complicated because some tasks can be more important than the others, and we don't want to follow exactly the order of first in, first out. And for that reason, we can use something a little bit more advanced called a priority queue, when each task comes with a priority, and the order that these tasks will be performed depends on their priority. And we will talk about priority queues in later videos. So let's get back to queues, and let's talk about the main operations that we have here. So what are the operations, the interface that the queue abstract data type um, provides? Okay. So the first operation, similar to stack, is create. So if you're implementing this in C++, implementing queue in C++, then you will have a class called queue, and that class is going to have a default constructor, and that will be this operation, create. And the idea is that this operation creates an empty queue, a queue that does not contain any keys. Okay. Now the second operation is push. But when in the context of queues, sometimes that is called enqueue. So you want to add a new key to your queue. And so what this does is that it adds key, this element here, um, to the back of the queue. Now, front and back, it will be more clear later on when we see an example. But again, if you're thinking about a line that people are staying in the line, the new person goes to the back of the line, and then the first person that will be served is the person in front of the line. So that's the terminal. That's where the terminology back comes from, right? And then we had pop, and in the context of queues, sometimes that's called DQ. So DQ removes and returns. Remember, first in, first out, right? Remove and returns the element that is added to the queue least recently, right? So the least recently added key, okay? The key that has been there the longest, right? So first in, first out. Now, one thing to note here is that I said remove and return, right? So it does both. But in C++, for example, this operation of DQ is implemented as two separate operations. One of them only removes the most recently added key, and then the other one returns it without removing it. And they are called, so in C++, implemented as two member functions that we will see later on in this video. Okay? And finally, the last operation that I want to talk about is, again, similar to stack. We want to know whether or not our queue is empty. So we have this other operation called empty, and it returns true if the queue is empty. It's empty, it's false on it. Okay, so the operations are more or less similar to a stack. The difference is the behavior. In the stack, we had last in, first out. So when you DQ or pop, the element that you're removing is the element that the most recently added element. But in a queue, is the least recently added element that will be removed and returned when we DQ. Okay, now let's do an example to make sure that we understand how these operations work, and then I'll show you the built-in class called Q in C++ and the operations and how they're implemented in C++. So let's say, starting with an empty queue, starting with an empty queue, we do the following. We perform the following operations. We enqueue, say 2, then we enqueue 7, then we enqueue, say 5. Okay, let's see what's going to happen so far. So when we enqueue2, at the beginning, the queue is empty, and we are going to push from this end and pop from the other end, just like a queue, right? You join the queue in the back, and then the first person that will be served is the person in front of the queue. So we push 2, so 2 goes here, and then we push 7, so 7 goes here, and then we push 5, 5 goes here, right? So 5 is the last person that is added to the queue, 2 is the first person, and obviously if we pop or DQ, 2 will be removed and returned. So if I DQ now, what I get is it returns 2, and also it removes it from the queue, right? Which means if I DQ for the second time, then the person in front of the queue, or the least recently added key is 7, so that is the key that will be removed and returned. So it returns 7 and removes it from the queue. Now, if I push or enqueue another key, like 11, again, that will be added to the end or to the back of the queue. And again, if I dequeue, the least recently added key is 5, which will be removed and returned. Okay, so that's the idea, but it will be, this idea, we will make it more precise in the next video when we talk about in more detail about the implementation using an array or a linked list. Now, the final things I want to talk about in this video is how this is implemented, not how, but show you the implementation of C++ and the operations and run a test on that. Okay, so first of all, if you are going to use the built-in class of queues in C++, you should include queue, okay, and the standard namespace. Now, to declare a queue object, what you need to do is you say queue, and similar to stacks, since this class is implemented using templates, you have to specify the type of the elements that you want to put in this queue that you are creating. So you say in angle brackets, int or a string or double, and so on, and then give it a name like Q1. So that's the equivalent of the create operation that we talked about, right? The constructor will be called and a new queue will be created, which is empty at the moment. Now, if you want to enqueue elements in it, then the operation for that is called push. So I can push integers in my queue. So I can say q1.push, say 12, and then q1.push 3, and q1.push 7, right? And then, as I said, dequeue is divided into two member functions. If you only want to know what is at the front of the queue, then there is a function called front. So we can say something like cout q1.front to see what's the least recently key pushed into this queue. But if you only want to remove the element on the front of the queue, then the operation for that is pop. So q1 dot pop removes that element. Okay, so in this case, if I run this code, what we expect to see, since we added 12 and then 3 and then 7, the least recently added key is 12. So front is supposed to return that. So 12 should be written on the console. And then when I call pop, the same element, the least recently added element, which is 12, will be removed, which means that if I call front again, this time, the least recently added key is 3 because we removed 12. So 3 will be returned by this call to front, and it will be written on the console, and that's easy to check. Now, in the next video, what we're going to see is how this abstract data type can be implemented using one of our basic data structures, namely a string lineage.